In this tutorial we're going to look at the inverse and what it means mathematically. But first of all, let's do the classic and look at what Google will say. And Google says that the inverse is the opposite or contrary. So we're trying to think of something that does the opposite. In mathematics, we know things like sin and inverse sin are the opposite. Squared and square root are the opposite. When we do equations, times and divide, teach my year 8s at the moment, that's what's happening with them. So we're looking at something that does the opposite. If we look at images, then a lot of mathematics comes up. And we get this double pattern going on, and this line coming through the middle, which I'm going to discuss with you. And I always think, and you guys won't because of the digital age of photos, I think of negatives with photos. Whereas when we looked at photos, and if we take, say, this photo here, that on a negative, the opposites came out. So when it was light, it looked dark, and when it was dark, it looked light. Like I said, I'm sure that doesn't mean too much to you guys, but to me, that's what sticks in my mind. So, let's choose an equation. Well, in this case, we're going to choose y equals 4x plus 3 divided by 2x plus 5. And you may know, or may not know, that that will have an asymptote. You can think about where that asymptote is, or asymptotes, there's a vertical one and a horizontal one, and equally where it crosses the y-axis. If you want to do that, please pause the video now. That graph looks like this. And we can talk more about that graph, but for now we're focusing on the inverse. So, how do we do it? Well, if we're looking at this equation, and in this case we'll call it y rather than a function, but we know we could call it a function, then what we're really saying is we're going to switch all the x values for the y values and all the y values for the x values. That comes from a basic flowchart equation. So if, for example, with my year 8s we were doing, say, y equals 3x plus 2, I may get them to see that as we put in x. What do we do to it? We times it by 3. We get an outcome, which is 3x. Then what do we do to it? We add 2. And our outcome is 3x plus 2, or equally y. When we do the reverse, we're going this way. We're doing the inverse. So, what do we start with? Well, we're not starting with x. We call what we start with, sorry, we're not starting with y. What we start with is we call x. Okay, so we're putting x in. What do we do? Well, we're not adding 2, we're taking 2. So it's x take 2. And we're not timesing by 3, we're dividing by 3. So it'd be x take 2 divided by 3. This would then become our y. Now, in inverse mathematics, we don't call it y because we're using functions, which makes it clearer. We'd call this one fx, and we would call this one, say, gx, because it's a different function. But when we come back the other way, we can call it gx again because it's something different, and we want to relate it to this. So the inverse we write as g to the minus 1x. So inverse is always written as the minus 1. Okay, so therefore, let's follow the same with here. We write the same equation out again, but instead of writing x, and this is a more complicated one than some of the ones you'll start with, we're going to write y. Let's use a different, brighter colour. And here where it was y, we're going to write x. Now, we're going to rearrange that. Bit tricky, but we can do it. And I may leave you to think about that for a minute. You may want to pause that video again. But I'll now keep going. We've got x bracket 2y plus 5, because I've times both sides by 2y plus 5. I'm going to expand the brackets out. 2xy plus, 5x equals 4y. I'm going to collect like terms. I'm trying to solve for y. So let's collect like terms. 2x plus y minus 4y. That's incorrect. I hope you spotted that. 2xy equals 3 minus 5x. This is the trick that many of you may not remember. You may have got to this point, but what's the next step? Have a think about that. We're going to factorize it to take out the factor of y. And the last step, bring it over to the other side, or divide by 2x minus 4, which will give us 3 minus 5x divided by 2x minus 4. Or, what we really need to write is not y equals, but we need to write f to the minus 1x equals. And that is our inverse. Now let's see if that's true. We now take the graphics calculator and come down to here, and we type in, what was it? Fraction, so alpha f1, 3 minus 5x, 2x, take 4, and we graph that. It looks different. But what was that lines all about a minute ago? Well, what we're really doing, since we're switching all the x and the y, and let's make this bigger so that you can actually see it easier. So let's make this a bit bigger for you. We need to make this window square. At the moment it goes from minus 10 to 10 in both directions, but it's a rectangular screen. So if we now go into zoom, we can make it a square screen. But since we've switched it, all inverses, and I'll repeat that, all inverses will be a reflection in the y equals x line. Why is that? Well, because y becomes x and x becomes y. And if we look now at the graph, we can see that it's a perfect reflection. The blue lines and the red lines are a reflection of each other through the line y equals x. Thank you for watching.